Here I am to present our soil topic is compressibility and consolidation regarding to soil mechanics. It has a physical significance that many of the structures are founded on a soil. In a soil, there is a property of compress its volume. After that compression, a superstructure or a building should be settled. By these settlement, secondary forces is also generated on the buildings. Now we discuss about the what are the what is the major significance of the compressibility and consolidation. There are major structures which are water tanks, chimneys and etc. which are founded on soil, and after that it should be sink or settled. It is a harmful to us. So we studied about the compressibility and consolidation. First of all, you it has weightage of in gate at least 4 to 5 marks. In 4 to 5 marks, obviously in that two question definitely asked in gate examination. By preparing for the gate and crack the gate exam, you will going through a PSU sectors, some government exams, and for IITs and NITs for your further study regarding to MTech and PhD, which you have. In that you also connect with the new traditional techniques about the civil engineering and you in research fields. So prepare yourself and doing best in gate examination. Now comes towards the what is the phenomena of the compressibility and consolidation. First of all, we discuss about the soil three-phase diagram. It is a three-phase diagram. It is not an actual diagram, but it is a graphical representation of the soil in which solid water and air which have their position. Now, we applied a compressive load to these soil mass. Now this soil applied by these, the air should be expelled. Expulsion of air. Now expulsion of air, this expulsion is reduce the volume immediately. Okay, this phenomena is called compaction. This is called compaction. Now again we applied the compressive load. So the pore water is expelled out. Expulsion of pore water. Now when the water is expelled or water is removed in the pores of the solid, it's called 1 degree consolidation. It's called 1 degree consolidation. After again, if we apply this compressive load and increase its compressive load, now it's going to this situation. After this situation, again if we apply the compressive load, then it goes to rearrangement of clay particle. In that case, the structure of clay particle is rearranged to the flaky to dispersed structure, and by this rearrangement, this is called 2 degree consolidation. Now we discuss the compaction is done in case of cohesionless and cohesive soil, but in case of coarse grained soil, there is a large voids in between the soil solids. So the water is removed in the pores by the gravity load. So there is no 1 degree consolidation. In there, no 1 degree consolidation. In coarse grained soil, there is coarse grain, no 1 degree consolidation. Okay, in case of clay, 2 degree consolidation is done which is depend on adsorbed layer and the viscosity of the adsorbed layer fluid. If the viscosity is increases of the absorbed layer, the layer is expand and the gap between the particles is also increased. So there is no compressibility. Okay. So what we notified in that coarse grained soil is doing only the immediate settlement, but the clay soil is also doing the 2-degree consolidation, and cohesionless fine soil is also do 1-degree consolidation, but not 2-degree consolidation. 2-degree consolidation is only clay particles, and it is depend on the adsorbed layer and the viscosity of the fluid which is absorbed on the surface of the clay particle. In the clay particle, if the viscosity of the adsorbed layer is increases, the gap between these particles is also increases. By that, there is no compressive force in that. Now we discuss about the formulation of the consolidation. In that, if we see, this is the saturated soil system. In saturated soil system, solid and liquid. Okay. Now, what is the void ratio? E equal to volume of void equal to volume of solid. Now we assume the volume of solid equal to 1. We assume volume of solid equal to 1. So the volume of void equal to 1 into E. So the volume of this is E. Okay. Now by applying the compressive load, there is decrease in the volume of the soil. This is solid. Now the water is expelled out and the volume changes delta V. Assume delta V. It is changed to delta V, or we told it is a E final, and solid volume is as first, because solid are not compressed. It is only for 1-degree consolidation. It is, now we discuss only 1-degree consolidation. In 1-degree consolidation, there is no rearrangement of the soil particles, so the volume of the solid is equal to 1. Now the change in the volumetric strain is denotes the rate of consolidation. Delta V. What is the strain of volume? Delta V by capital V. Now find out the delta V. How you find the delta V? This delta V is actual volume equal to how you are find this value? Delta V. This is delta V and the actual volume of the soil. Okay. Now come. Assume in that delta V the void ratio is changed delta E. Okay. This is changed to delta E. Now we put that value. First of all, you say there your soil have 3-dimensional continuum system. In 3-dimensional continuum system, this is Y, this is Z, and this is X. Now I prepared a diagram of the first upper stage. Now if we see, this is the diagram, and this soil is going to as like that. Okay. it has infinity and it go to infinity. Now the whole 3-degree consolidation system is changed into 1-degree consolidation because these dimensions are infinite. There is no lateral strain between these axis and these axis. So there is change in only height. So overall consolidation system is changed to 1-degree consolidation. How? A into delta H by A into H. Why we put that value A? Because if you know that surface is also have some voids, assume this is area of voids. Now you want to the area remove that voids, A minus AB, A minus AB, but these container means infinite to infinite, so area is infinite into infinite, and after that these void ratio are, these area of void is so minimum, so this is A net area is neglected, this is 0, A net equal to A. Okay, now this is cancel out, delta H by capital H equal to delta V by V. Okay, now put the value from there. How you put that value? Delta H or delta V is equal to delta E. Now total height is 1 plus total height is, oh diagram media, solid 1, and this is E naught or E both. Okay, 1 plus E equal to delta H by H. Now there is delta H equal to delta E 1 plus E into H. It is a settlement in the soil structure. After that, how we do that compressibility test? We done this test in odometer. In odometer, there is a soil specimen. This is a soil specimen and some dial gauges. These are dial gauges applied, and load is applied to the soil. When we applied load on that soil, it should be compressed and the water is removed from there. Water is removed. No one asked the diagram in gate, so don't go to my diagram. Only discuss about the what is the technique. Applied the load, water is expelled out. Again applied the load till there is no difference between the volume of the soil. We applied the load, successfully increased. After that, a stationary volume is achieved in that soil. After that, we again leave it to expand in its original range. Again we remove it to its actual expansion. When you leave it, it should expand and expand to a limit. Note, put it in oven dry and note it down its weight also, and find out the how volume it's reduced of that. After note down that volume, you also find out the rate of the consolidation in that. Okay, now there is two types of method which is used to find out the rate of consolidation. First of all we find out important parameter of the consolidation. Now start with the two most important parameter of the consolidation, which is void ratio and effective stress. Okay. As the graph between the effective stress and void ratio is called a compression curve. It is two type of compression curve. First is on the basis of only arithmetic scale and another with the log scale. Why we applied the log scale? Because there is more variation in the value of the effective stress. So we want to analyze the all type of data which is included the effective stress. We applied the log basis. This is a log basis and this is arithmetic basis. This is arithmetic and arithmetic. Now if I applied a value of sigma, if this value is the highest value of a soil, if it is a value of sigma is greater than sigma naught. Sigma naught is the past compressive force. Past compressive force which is observed on the soil. If this value is applied greater than sigma naught, it is called normally consolidated soil. Okay, normally consolidated soil. If this value is less than, if value of sigma naught is greater than the value of sigma, then this is called over consolidated soil. Now over consolidation ratio equal to sigma naught. These are effective stress, both are effective stress. Sigma naught by sigma, these values. Okay. Now discuss about the curves. In that curve, if the value of void ratio is decrease with respect to the stress, in that case sigma is less than sigma naught, it is called the over consolidated soil. In that the convex upward curve is found for over consolidated. After that it is going to convex downward in that case. Now again we remove the old load on the soil. It is unloading curve which is going to that type, and after that again reloading curve on that soil. Now in case of log, this curve have a slight curvature, but it is a again straight line curve. So the normally consolidated clay have straight line curve in case of log basis, but in case of sigma it is decrease in a parabolic manner. Okay, now we discuss about the some coefficients. First is compression index. Now first is compression index CC equal to value of sigma E1 E2 minus E1 by log sigma 2 minus sigma 1. Okay, in that case E2 minus E1 equal to delta sigma and log sigma 2 by sigma 1. What is sigma 2 by sigma 1? Sigma 2 is equal to second effective stress and it is first effective stress. Now it is a void ratio on effective stress sigma 2 and it is effective stress on this. Now come to coefficient of compressibility. Okay, coefficient of compressibility. This is denoted by AV. In case of AV, there is this is void ratio E, which is decreased as sigma. This is sigma 2, sigma 1. This is regarding to E1. This is regarding to E2. It is E2 minus E1. E2. What is the E2 value on the sigma 2? Sigma 2 minus sigma 1 equal to delta sigma, delta E by delta sigma. It is a negative value because as the effective stress is increased, the value of void ratio is decreased. Now come to volume compressibility. Volume compressibility is defined by mv. Now come to volume compressibility. In volume compressibility, change in volume with respect to unit change in effective stress. Now it is denoted by, this is volume, this is delta V by V equal to delta E 1 plus E. We derived that formula in earlier. Now this is value and this is the effective stress, change into effective stress. This value is going to AV. Now this AV and this value, this is the value of volume compressibility. It's okay. Now the some numericals we discuss in next lecture.